Practicing with number sets, meeting the requirements for TEKS 7.2. Now, how do we put numbers into sets? Well, we put numbers into a set based upon those numbers sharing characteristics. There's something about those numbers that's alike. We'll talk more about that during the video. Why do we put them in sets? So that we can better understand how to use those numbers for certain functions. We'll talk more about that as well. Before we talk more about numbers, let's first talk more about sets. Sets are a collection of information that shares characteristics. Here I'm using an example of geography. We know that in the set of cities, we can put places like Dallas, Houston, and San Antonio. They share characteristics of cities. They're large urban areas where people live. We also know that Texas is not a city. It belongs to the set of states. And it also includes, in this case, those cities of Dallas, Houston, and San Antonio. So the orange set is also part of the yellow set. Finally, the United States is made up of more than just Texas. There are 49 additional states, but there are also territories like the U.S. Virgin Islands, Puerto Rico, and other locations. This set of the United States also includes the state of Texas, which also includes all those cities. Finally, North America is made up of the United States, but also includes countries like Canada, Mexico, Greenland, and there are some others. These are all part of North America, which includes the United States, which includes the state of Texas, which includes the cities of Houston, Dallas, San Antonio, and some others. Let's take a look at another example a little bit closer to home. We know that room 132, room 231, room 276. These are all classrooms, and they belong to the set of classrooms. Their shared characteristic is they are places where instruction occurs. Those classrooms are part of the campus known as Stevenson Middle School. But in fact, there are other middle schools like Connolly, Briscoe, Jefferson, and some others that also include Stevenson. And all of them are schools in Northside School District. So Northside School District includes all of those middle schools, as well as Stevenson, and the classrooms inside of them. When we talk about number sets, these are the sets we'll be working with: natural numbers, whole numbers, integers, and rational numbers. Natural numbers use the symbol n, and they are in fact counting numbers. When we talk about natural numbers, we're talking about all numbers used to count, beginning at 1 and going up by ones. 1, 2, 3, 4, and so on. When we look at a number line or graph of natural numbers, this is what we expect to see. Numbers beginning at 1, going up by ones. The next set of numbers are called whole numbers, and they use the symbol W. Whole numbers include all of those natural numbers and 0. So you can see here the relationship between natural numbers and whole numbers. Clearly, whole numbers includes all of the natural numbers, those counting numbers, and 0. On this number line or graph, you can see all of the natural numbers in orange, which now, to make up the set of whole numbers, includes 0 in yellow. The third set of numbers are called integers, and they use the symbol Z. Why Z and not I? Not everyone is an English speaker, and in fact, years ago when these sets were put together, in this case, it was a set of German mathematicians, and the word for numbers in German is Zahlen, which begins with a Z. The set of integers includes the entire set of whole numbers and their opposites. So now we begin to see negative numbers. In this picture, you can see that the set of integers includes all of the whole numbers and all of the natural numbers, and now their opposites as well. Why all these sets? Natural numbers are used for counting. To show the absence of value, we have 0. And then now to count down or show the loss of something, we now have negative numbers. On this number line, you can now see all of the natural numbers in orange, the inclusion of 0 to show whole numbers, and all of their opposites in green. These are all integers, which includes natural numbers and whole numbers and their opposites. The last set is rational numbers, which use the symbol Q. Now, once again, why Q and not R? In a moment, you'll see exactly why. For now, you just need to know Q is for quotient. Rational numbers is the set of numbers which can be expressed by the quotient of two integers. In other words, any value that can be expressed as a fraction. And since you know a fraction is a division problem, and the solution to a division problem is called the quotient, you now understand why Q is the symbol for rational numbers. This is now where we begin to see values that are a part of something, a fraction, a piece or part, more or less than 1. They can be expressed as fractions, decimals, or percents. And now we begin to have numbers that allow us to measure things. In this picture, you can see that the larger blue set, rational numbers, includes everything inside of it, integers, whole numbers, and natural numbers. Every natural number is a whole number, which is an integer, which then is a rational number. The smaller sets are all part of the larger set. Rational numbers give us the opportunity to begin to measure things. Not everything is measured exactly. Not everything will be 1 or 2 or 3. You might have something that's 1.5, or only 1/4 of something. Or maybe something has gone up by 250%. We need ways to measure, and rational numbers allow us to do that. Integers allow us to count down or show the loss of something. Whole numbers, which include 0, allow us the opportunity to show the absence of value. And natural numbers, those numbers you learned first, early on in life, allow you to count. On this number line or graph, you can see all of the number sets we've been talking about. Everything on this screen is a rational number because rational numbers include natural numbers, whole numbers, integers, and all values that can be expressed as a fraction. That doesn't mean they have to be a fraction. It just means they must be able to be expressed as a fraction. So, for example, -2.5, that's not a fraction, that's a decimal. But I could write it as -2.5. A mixed number includes a fraction. I could even write it as -5/2, which would be the same value expressed as an improper fraction. This is the same number line, just drawn a little larger, so that you can more easily see all of the natural numbers, those counting numbers, which now includes 0 to make whole numbers, their opposites in green to make integers. And now finally, those numbers or values that fall in between them are rational numbers. Rational numbers are any and all values that can be expressed as a fraction. I show you this picture because it's important for you to understand that not every picture will show the sets drawn in exactly the same way. Earlier, I had the orange, yellow, and green ovals drawn more toward the bottom of the blue circle. Here you can see they're more toward the left, but they still depict the exact same idea. Each set is a part of the larger set, all the way from natural numbers through rational numbers. You may even see the picture drawn not using circles or ovals. Here, they're using rectangles. But it's the same idea. All of the number sets are still exactly the same. All of their shared characteristics are still exactly the same. The only difference is the picture is drawn somewhat differently, using rectangles. But the orange rectangle of natural numbers is still part of the yellow rectangle of whole numbers, which is still part of the green rectangle of integers, which is still part of the largest rectangle here, the blue one, rational numbers. Let's see if we can work together to build the set of numbers. So let's start with the smallest set, natural numbers. You may remember that natural numbers are all those numbers you use to count, the numbers you learned first. Natural numbers uses the symbol of n and includes numbers like these, 1, 2, 3, 4, and so on. The next larger set is called whole numbers. Whole numbers use the symbol W, and they include all of those natural numbers and 0. Natural numbers allow us to count things. Whole numbers now give us the opportunity to express the absence of value with 0. The next set is known as integers. Integers uses the symbol Z. You may remember earlier I told you that's because the German word for numbers is Zahlen, which begins with Z. Integers are all of those whole numbers and their opposites. So if I can count 1, 2, 3, 4, well then I can also count -1, -2, -3, -4, all of their opposites. So this is where we begin to see negative values. And these allow us to count down or to show the loss of something. The last set is called rational numbers. Rational numbers use the symbol of Q. And that's because rational numbers are the set of numbers that can be expressed by the quotient of two integers. In other words, numbers that can be written as fractions. And since we know a fraction is a division problem, and the solution to a division problem is known as the quotient, this symbol makes sense. And here's where we begin to see values that allow us to measure things. So I might have a fraction 2/7, or even a negative fraction, -3/5, a mixed number of 1 3/4, a decimal of 0.6 or 6/10, even a negative value of -2.5, or even percents, 350%. These numbers allow me to count, to show the absence of value, to count down or to show loss, or to measure things. These sets are made up by numbers with shared characteristics. This is the set of numbers we'll be working with this year. In this lesson, we learned about and practiced with number sets, meeting the requirements for TEKS 7.2.